I got these two interesting little pieces of technology, and really what this is, it's a signal generator.
If you look up signal generator on AliExpress, you can find them right here. All of these ones should work fine enough.
Yeah, I think it's a pulse generator as well, which is really cool. It doubles as it. You can like change it to PWM and pulse. And this is it's a three-part thing. It's an oscilloscope, it's a signal generator, and it's also this little thing here is like a components tester, so you can put like a capacitor in it, and it'll tell you what it is. It's really nifty.
Similarly, if you look up oscilloscope, you can find pretty cheap ones like this, There's all kinds of multimeter tools. It's pretty nice.
If I turn my okay, so this runs on around 3 to around 3 to 30 volts, and it goes from, I guess it's let's 1 hertz to all the way to 150. Like, see, that's about 1.5 thousand. You can get up to 10k. You can get up to 150,000, I think, is like the max. So anyway, let's just leave it on that. Now this, it cost me about 60 AUD. It's a FNIRSI, I think Finersi, a strange brand name, DSO TC3 oscilloscope. We hold this to turn it on, and this is it's a Chinese-made oscilloscope, and for what it is, it's honestly really nice, because oscilloscopes can run you, geez, they can cost like hundreds of dollars, thousands of dollars. This one, of course, it's only pretty much an audio oscilloscope, because it only goes up to 500,000 hertz, I think. So 500,000, is it 500,000? I don't know, something like that. So as we see, oscilloscope generator means like signal generator, as we can see here, which is pretty cool. So if you were doing like audio work, and they've got a cheaper version of this, which just has the generator and oscilloscope. But this one's got a component tester, which is really cool. As I said, you can put them in, and it just tells you, and I don't know, tools, whatever. And I think you can check voltages. But anyway, we go to oscilloscope, right? We see this screen here: voltage max, voltage min. I don't know, voltage R's and M, whatever. It says frequencies and duty and all that. So what you need is a probe, which has a negative connector there, and it has a, if I pull this down, it's got a little hoop, and I can pull this off, and it's got like a needle tip. So here I plug it into the one which says DSO, and what we do for our signal generator, now the signal generator has, we go here, it's got like a QR code, I think, for if you want to look up instructions, but it's got voltage positive, negative. So your positive goes to the positive of your battery or your power supply, and negative of the power supply. And then there's PWM, I think that's called pulse width modulation, I would imagine, and then ground. So PWM is like your positive of this, so it goes, I plug it into the oscilloscope.
I'm also using breadboard cables to plug into the signal generator, but you could just use soldered cable or just small enough cable.
You can see there, it's been plugged into that, and then negative, I plug into the thing that says ground. And now we see, which is really cool. So this is on 4002 hertz, and we can see there, frequency, it's saying it's around 4000. And what's that, like 32? So it's not perfect. If I switch this down a bunch, see how the frequency changes? The frequency is like FEQ. So I'm going to push, like, tank this down, and notice how the waveform, look at that, square waves, and you can do like an auto, there's like an auto check to get it into, you know, size. And for Vmax and Vmin, it's so I've got it set to 9. So it's like, I guess if you think, you know, positive, negative, like AC is going up and down, you can see, because this is up, like that's the peak of the voltage, which is like 4.5, and that's the volt Vmin, which is down, right? This is up, down, up forward, so it's kind of staying at that voltage. This is producing a square wave. So if you maybe you had like an AC power, it'd be a sine wave, like good AC power, of course. So something else that's kind of cool, you can get these mini Tesla coils, which all it is just a this is like a 12. These are like a power cables, right? So hang on, you buy these off AliExpress as well. It's just a regular power, like a DC 12-volt power cable inlet, and there's a ceramic capacitor, there's a switch, there is a resistor, I think it's like a 2K or something, I forget. And there's like looks like a MOSFET resistor, MOSFET transistor, and there's an LED in the middle, and also the coil tower. Now this one I somehow broke when I touched a light bulb to it. I touched the light bulb to it a bunch, but for some reason it just something broke. Wireless power transfer. So I want to put it near it. How cool is that? Okay, so this thing in front of me is a super simple audio amplifier. Now if you understand audio amps, there's two, sorry, it's all hairy, that's gross. There's preamps and there are regular amps, and a preamp is a signal amplification, I believe, and a amp is a post signal amplification. So it's like, this is your signal, is it before or after? So that's if it's a preamp or an amp, right? Something like that. And amplification is, of course, amplifying amplitude. Now, what is amplitude?
Alright, so I'll do my best to explain this because I don't fully understand it all, but essentially amplitude, it is, I believe, measured in voltage. This is an air pressure diagram, don't mind it, it's the same kind of thing. So you can see like the higher and lower areas. If you see this as a sine wave, an AC sine wave, it's raising to a certain amount of voltage. So you can think, let's just pretend this is 1 volt and a negative 1 volt. So it's going from like 1 volt and then it's kind of going backwards to -1, or it's flipping from like positive to negative. So I guess the amplitude is like the voltage, really. It's the peaks, I guess, the highest points. The amount of like positive and negative voltage. And then of course hertz is like the speed. So how many times is it flicking up and down per second? That's your hertz. 5 cycles a second is 5 hertz, right? Okay, so if you're wondering where I found my audio speaker diagram, this is like the easiest one I could find. It's from this, here we go, the IRFZ44N, the ultimate guide to this powerful MOSFET capacitor, from nextpcb.com. I'm pretty sure these guys are just trying to sell these things, but anyway, it's an interesting thing. It's like, oh, look at that, it's a voltage. You can be used as a voltage regulator, you can use it as a delay timer, or an audio amplifier, or motor controller. It's like, yeah, that's nice. So pretty much as we can see here, pretty much that side to the capacitor, potentiometers middle, potentiometer positive, negative, so the audio in and out. Now the audio in and out is a signal generator, and the speaker in this case is our antenna, and of course it's 3.7 volts. That's pretty much enough. We can actually use a little less, but it's pretty much enough. Really, it depends on current. I just want to pre-say, I don't really know enough about amplifier circuits or electronics to know if this circuit really works, so do take it with a grain of salt. It does seem to work. It does seem to, when I move the potentiometer, things do move, like change in values, so I don't know. So this page here is on tutorials point, basic amplifier. It's worth a read to try to understand amplifiers. This is a basic amplifier circuit. You can see here, this is our input, and this is our output around here. Now this is using a, was it NPN transistor. Again, it's good to learn about transistors. You've got the NPN, you got the PNP. And we can see here, so if I am correct, you open, you apply voltage to the base. What happens is that I would assume does current go from the, what do you call it, the collector to the emitter? Is that correct? And then on a PNP, does it go from the emitter to the emitter to the collector? Imagine you're allowing the circuit to flow from here to here or here to here if you apply power to the base. That's pretty much how a transistor works. And then there's all this weird stuff that you can do with it, because it can amplify from transistor amplification, how this stuff works. As we can see here, resistor, and this one doesn't have any capacitors, and we see this is where the power negative and positive goes, the top and the bottom. And this is an actual proper circuit. Now I tried to make this one, except I had two problems. Number one is, what value are all the resistors and capacitors? I kind of looked it up, because you can see here, C in is what you call a capacitor, a coupling capacitor. Oh wait, no. CC is a coupling capacitor. This is an input capacitor, and then there's an emitter bypass capacitor, and here we can see a load resistor there, and all these other, there's all these words. Or you just go on AliExpress, buy yourself a $10, $20 amplifier. And really what you want is a mono amplifier. Now if we go down here, for example, this is the simplest one I could find. You can see here on this one, it has a audio positive negative, or a speaker positive negative, which is where your coil would go for the experiment that we're doing. And here is our power positive negative. And then finally here is your audio input or signal generator. And you can see, because it's only mono, it's only got a positive and negative. So it's a very simple piece of equipment. Rife machines. Okay, Rife is this guy who figured things out and wrote a bunch of books on all kinds of interesting applications of frequencies and all kinds of other cool stuff. Look, I don't know. We'll do a research on him some other time. I can't really remember. Look, the reason why I'm making this whole video to explain this stuff is because, do you want to pay this $1,000, $1.4 thousand? What is this? What is this? This is crazy. What do you even get when you buy this thing? Now, here, Rife machine. The Rife machine is a device that emits low energy electromagnetic waves, also known as radio frequency electromagnetic fields, RF, EMF. It was developed by Royal Raymond Rife in the 1920s and 1930s. And its original purpose was to detect and destroy cancer cells by tuning into their electrical impulses. And supposedly, the claim was that it could treat cancer, eliminate bacteria and viruses. Of course, there is a lack of evidence. Well, if there's a lack of evidence, it means there's a lack of experimentation. So I'm on this website, royal-rife-machine.com, and I'll put this in the description. We make no claims to the efficacy of the frequencies, and I also make no claims. In my experience, I have found that these do work, actually. I can feel these do stimulate the areas of the body that they say they stimulate. You just look up whatever you want. Here you go, saw_throat, so 2720, which means 2000 hertz and 720, which this is the frequency. You can see, and they've got multiple frequencies here, and they've even got point and a half. So try these out, right? Plug these in. This is what you plug into your signal generator, and the audio amplifier amplifies the signal, and then the emitter, the coil emits the frequency, right? That's how this works. And you have to make sure you don't overdo the power. Just make sure you're not using too much current. If you're using a DC generator or batteries or whatever. Anyway, let me plug this in and show you.
Okay, here we are. Now what I have is I have plugged my signal generator into a 9-volt battery. Anything 3 to 9 volts, 3 to 12 is probably fine. Now at the frequency I wanted to tune it for is 270 20, and you've got to make sure it says out. Now I have the positive negative of the pulse width modulation and the ground connected to my thinger here, and that's, so this is the amplifier, so it's signal generator, amplifier, and amplifier is connected to power. I've got to turn the power on, and again, current can go really high and the voltage will go higher, but I'm just going to have it at around half. And if I adjust this, what happens is the voltage starts to go down. And of course, if you know what's our voltage times amperage, and of course you want to, at least because I'm using a custom one, I want to touch my MOSFET, which is starting to get really hot. Oh, he's hot. He's very hot. Make sure it's not too hot, right? That's why I have it on half a amp. Anyway, this is doing its thing. Do I feel my throat being stimulated?
I had to change around my coil, and it's also a new day, so don't mind the different setup.
Okay, here we are back again. Now, of course, the question of the video is, does it work? Is there any point of making this thing if it's going to just not work? Now, of course, number one, it depends on your electronics and your electronic skills. If you're going to make this yourself, like I did make the amplifier circuit, you're going to need to, it's going to need to work. If you're going to make the coils yourself, you're going to need to know how to strip the wire and do all that stuff, right? So you could have electrical issues. Of course, there's ways to test it with a multimeter. You can also use an LED to make sure that you are getting connection between everything. Depending on the voltage, you don't want to blow your LEDs. Assuming everything is electrically functional, like mechanically functional, first thing is, here is our EMF meter. Now, just before I say that, I've got a new coil here, because I accidentally had to break my self-made capacitor, or at least one of them. So instead we have a...
Don't mind the weird shape. It was from an electromagnetic motor that never really got working. Otherwise, it should be fine. It just create a bunch of electromagnetic fields.
An LC circuit, which is just a capacitor and inductor or magnetic coil, or basically just copper coil in parallel. You can see there, so it's just connected. The positive and negative. We're getting both a electric and magnetic field, and we're not getting any radio frequency because I guess it's not powerful enough, unfortunately. But we could, there's some experiments, with one of these fellas. Once I fix this, or build another one that we can do. But at least you can fundamentally see that it is so. From a mechanical standpoint, the whole thing works. That's what we can say, at least number one. Number two, does the frequency, currently it's on 1 for the bladder region, because I thought, that's an easy way to test it out, right? And yes, I can say with certainty, I can feel that. I can feel the energy going to there. Number two, the current, if I increase the current, it does increase the power. But the problem with this is that my poor little MOSFET is hot enough to cook an egg on if I increase it anything more than about half an amp. So currently we are sitting on around 1.25 watts of power, which is pretty much nothing.
it still works. I can still feel it. I guess that's good enough, right? It still has a subtle effect. But if you, for example, bought an amplifier that was like a 10 watt amplifier or a 50 watt amplifier, that would produce a much stronger effect. It would also be much more easier than making one, unless you really know how to make amplifiers, and you can really. I've made a couple, and I still struggle to understand all of this, how it works, but I'm slowly starting to understand more of it. Anyway, go make one yourself. As I said, I just have a signal generator connected to a battery. See, the output of the signal generator is connected to my amplifier circuit, and the output of the amplifier circuit is connected, well, technically the power part, I don't know, is connected to my that, right? So it's I don't know, taking the frequency and powering the coil, and somehow it works, right? There's going to be different amplifier circuits, so they're going to have nice little outputs. This one does not have a nice output. You just kind of hook it up halfway to the power, and it seems to work. When I change the frequency, it seems to change where I feel it, right? So it does have an effect on the body, meaning this, at least from my experience, it does work. But of course, test it yourself, make your own. Because they are kind of stupidly expensive. There are some you can find for a bit cheaper, but you can make it yourself, so whatever. And yeah, it's good fun.